Let us quickly see how to work with Keil Microvision 5 for 851 programming. So I have already installed the Keil Microvision 5. I open that. So here, for the sake of learning, I will open a new project. So you can start a new Microvision project. Ensure that you have some folder, and you should remember the folder where you are creating. Let us assume I'm going to create a project called as tutorial 4, Qt 4. So now you can select this legacy device, and what is the microcontroller you want to work, you can select here. So here so many microcontrollers are there. So let us select this NXP. This board is available in our lab actually, so I prefer to take that board. P89B5RD2. So select this P89B51RD2. So this one, P89B51RD2. So this we can select. In this example only we are going to simulate, and we are not going to use the board actually. So please give us the startup.a51 is required. So you say yes. So once this is created, the source code will be created. Now you can create a new file. So you can create a new file, and I'm typing I'm pasting the same program what I'm having already. So what is this program is? So you can see I'm moving 1000 a data 1000 to DPTR. It means DPTR is going to point a memory called as 1000 H. Memory address is 1000, and I'm moving I move X is this move X means I'm moving from the external memory. External memory, the data is coming from 1000 to A. Since I'm saying at the rate of DPTR, since DPTR is pointing 1000, the data from the 1000 will come to A. Then I'm storing the value of A in B. Then I'm incrementing DPTR. So now DPTR is now 1001. Now again I'm moving the data to A. It means the data of 1000 is in B now. Now the area data of 1001 is in A. Now I'm adding both, add A comma B. So the data will be added and the answer will be in A. Increment DPTR. So now the DPTR will be 1002. Then A comma at the rate of DPTR. It means the A will go to the DPTR address. The DPTR address is now 1002. So A will go to 1002. Whatever the answer we summed up in A will go to to that address. Then here this is the way we can say halt. By halting the program, because short jump here. It means I'll be always here. I don't go anywhere else. So this is equivalent to halting. So now compile this program. Compile this program. So now we have to add this. You save this. Save this file. So here also here I will say add, and the extension should be ASM. .asm in the same folder you can save. Since I am written the program in the assembly language, the file name will be ASM, and try to add that file. So in the source group, add existing files. So here we have created this add.asm. You can add that. You add this. Now you can double click that. You can now compile. So if you compile, zero errors and zero warnings are there. Then you can build the program. You can rebuild. So actually we have to create a hex file and then flash that hex file to the controller board. But right now, since we are going to work in a simulation, we are not worried about whether the hex file is created or not. Now we are going to debug the program and then see the result actually. So go to debug and you say start debug session. So okay, so this is a evaluation mode. It is running. So here, if you want to run step by step, you can use this This symbol will help you to run the program step by step. And you can view the memory and then register. So you can look at here, watch windows, registers window is there. You can click that. So if you click the register window, the register will be displayed. If you want to see the flags, the PSW, you can click the PSW. This PSW will have the flag values. So you can click that also. So right now I'll click that. So registers values are there. And if you want to access the memory, you can go to the memory, you can go to the view and then memory windows. So you can select memory 1. So memory will be here. So here also you can look memory windows. So yeah, here it come. So there are three type of memory. One is program memory, that is a code memory. So we call it C colon. And other one is RAM memory. We call it as a D colon. And if it's a external memory, we have to call it as a X colon. So to go to this memory 1000, you have to type here X capital X you can use X colon 1000 H. So this is the 1000 actually. So whatever the value in 1000 is going to come to A, and whatever 1001 also will go to A, and finally we are adding and answer will come to 1002. So this is 1000, 1001, 1002. You can change the value here. For example, let us say this is 23 and this is 32 and this is 32. Yeah, now this 23 will go to A, 32 also will go there. A and B, and it will be added and answer will be stored back here. So let's do one by one. So now you can see DPTR is having 1000. So the first instruction is executed. So DPTR is now 1000. One more step. You can see the 23 have come to A, and one more step. This 23 has moved to B. Now DPTR is incremented 1001. Now 32 has come to A. Now both are added. B and A are added and answer is 55. And DPTR is incremented. And the 55 is moved to the memory. So this is what we want. So from the memory we can take the data and write, and then we can do here. And finally the program is halted. So the meanwhile you can check the carry flag. There is no carry formed actually. Let us say how to form a carry. If the answer is exceeding 255, there may be a carry may form. So let us debug again. So you can say stop debugging. Then again you start the debug. And then so here you give some number higher. Let us say FF. To make this data as FF. And this is 1. So FF plus 1 is 100. That 1 will be the carry will be formed, the answer will be 100. So now if you run the program, step by step, so 1000, FF is moved to A. Now 1 is moved to A. After addition, answer becomes 00. Answer becomes 00, but now check the carry flag. Carry flag is 1. It means whatever if the carry flag is affected, we can see in this carry flag. So by this manner, you can understand all the instruction one by one. You can write several instructions here, and you can see the behavior of the registers, and also you can access the memory. So memory now doesn't be anything because the answer is 00, but carry flag is 1. So answer is 100. So this is how you can use a Keil microvision software. Then rest all you should understand the instruction set of 8051, and you have to write different programs and to explore all the concepts using this tool.